Hello and welcome to another presentation, this time on the reciprocal trigonometric functions. Now we're going to firstly introduce the reciprocal trigonometric functions. Now why do I call them reciprocal trig functions? Well, because they are the reciprocal of the original trig functions. So for example, let's say we start with sine x. Well, 1 over sine x, and I'm sure this is probably coming back to you, 1 over sine x we describe as cosec x. Somewhat counterintuitively as well, because 1 over cos x we define to be sec x. And lastly, 1 over tan x, which I think it's worth pointing out is exactly the same as cos x over sine x, because tan x is sine x over cos x, is a cotangent or cot x. Now we just use these functions essentially because it makes the working out a little bit easier, because in the real world there are many situations which lead to utilizing the reciprocal trig functions. So they're just, new definitions of trig functions, and actually if you go a little further into FP2 and FP3 at A level, there's many other trig functions, and beyond that obviously at in degree level, but there's many other trig functions, for example sine, cosine, coth, there's lots, there really are. But at A2 they just need to know these three. Now we immediately find a couple of identities actually using the original identity which you need to know at AS. That identity is sine squared x plus cos squared x is 1. Now if I divide everything in this equation by sine squared x, I immediately end up with another identity. Because I end up with cos squared over sine squared, well that is cot squared. And then there I'm going to have 1 over sine squared, well that is cosec squared x. And I have an identity linking two of these new reciprocal trig functions. Now if instead I divide through the original equation, the sine squared x plus cos squared x is 1. I'm not using 3 lines on my equals out of pure laziness really, I guess. It's not something that mathematicians always draw. It is nice to see it though, because it is certainly an identity, but I'm not going to bother today. Sine squared over cos squared is tan squared. Cos squared over cos squared is naturally 1. And 1 over cos squared is sec squared. So 1 plus tan squared is sec squared. Really we should have the x's on that, but it's quite natural to often say 1 plus tan squared is sec squared, or sine squared plus cos squared is 1, but you're dropping the angle. Be careful with that as well, because students often drop the angle when they write it down, and that's quite bad practice. So we have two new identities, and let me just make it clear. Let's add identity by putting in that third line there. Two new identities for the students to learn at A2. Those identities can be particularly useful for solving equations involving these reciprocal trig functions. Now just before I get into that, I wanted to point out one very common misconception. Sine to the minus 1 of x. When we write that down, we mean arc sine x, which is naturally a very different function to 1 over sine x. So it's worth, whenever you introduce this to students, immediately saying that that is not the same as that, even though you might think it would be the same as that. So put a big line through the equals. That is not true. It's one of those situations, and this doesn't happen regularly, but it's one of those situations where the notation is actually quite misleading. So be very careful with the notation. Naturally, it's one of the reasons why we call inverse sine of x arc sine of x and 1 over sine of x cosec x. It's to distinguish between the two. They are not the same thing, and you have to be aware of students making that mistake. Okay, so let's get right on with it and have a look at solving trig equations involving these reciprocal trig functions. Now, this isn't super different from what you do at AS level. First thing we're going to do is get rid of the reciprocal trig function there, or turn it into its equivalent. Now, as we already mentioned, cot is just cos over sine, just as tan is sine over cos. So we're going to have 3 cos x over sine x. As soon as we do that, it starts to become a bit clearer what's going on, because I'm going to multiply the sine x onto the other side of the equation. So I get 2 sine squared x equals 3 cos x. And at this point, it's very, very similar to the kind of problems you get in AS, where you have a sine squared and a cos, or a cos squared and a sine, and really you're dealing with a quadratic in disguise. So I'm going to use the fact that sine squared is 1 minus cos squared. And if I multiply out that bracket and simplify it, I end up with 2 cos squared x. Well, let me just do it slowly. 2 minus 2 cos squared x is 3 cos x. Like with any quadratic, I'll want to put it all on one side of the equals, so let's have 0 equals, and I'm going to write cos as c squared, yeah? It just makes it a bit clearer what you're actually dealing with. 2c squared plus 3c minus 2. Naturally, factorise 2c in one bracket, c in the other. If you're like me, you're a guesser, and that will work if I have a minus 1 here and a plus 2 here. Now at this point we get cos x equals a half, in which case x will be inverse cos of a half is 60 degrees. Rule of thumb for cos is 360 minus, so I get 300 degrees. Now for the other one, I actually get no solutions, because cos x equals minus 2, but cos x never equals minus 2, and so you can ignore that part of the product there. You can just ignore cos x equals minus 2. And we have solved it, and by all means plug those numbers back into the original equation and you will find that the equation is solved. Okay, let's just do one more just so we get comfortable with this. This time we're going to solve cosec squared x plus cot squared x equals 2 from 0 to 360. Now in this one, because you've got a cosec squared and a cot squared, it seems much more natural to use one of those identities I proved in the very first few minutes, namely that 1 plus cot squared is cosec squared. So if I write that cosec squared as 1 plus cot squared, I end up with that. Now once again I'm going to define c, but this time as cot x, just to make my algebra a little bit nicer. So I've got 1 plus 2c squared equals 2, and so as you can see I'm going to end up with c equals, well, c squared equals a half, and so c is the square root, well, it's plus or minus 1 over root 2. Now remember, c was cot x, therefore tan x, which is the reciprocal of cot x, is simply reciprocal of those values, which is plus or minus root 2. Yeah, because remember c was cot x, and 1 over cot x is tan x. Let me write that down for you. And now I can do my inverse tan. Now let's just deal with a positive value first. If I do inverse tan of positive root 2, I end up with 54.7 to 1 decimal place. The rule of thumb for tan is just 180 plus, so I get 180 plus 54.7, which is 234.7. But if I now look at negative root 2 and do inverse tan, I get negative 54.7, and that's because minus tan x is tan of minus x, because tan is an odd function. But I get, yes, minus 54.7, add 180, I get 125.3, and then add 180 again, and I get 305.3. And I haven't missed any solutions, which is lovely. By all means, plug those values back into the original equation and check that they work. Hope that's given you a little idea of how we solve trig equations involving reciprocal trigonometric functions. The key thing is, don't forget the two identities, because they can be very handy indeed. They do come in handy as well sometimes in certain integrals, so also a possible place where they might be quite handy. Okay, thank you for listening, and yeah, I look forward to speaking to you again. Bye bye.